There are 5 sig fig rules that you need to remember throughout the entire year in chemistry. First one is that all non-zero integers are significant. For example, 8.397 are all not zero. So there are 4 digits, there are 4 sig figs. Trapped zeros are always significant. Trapped zeros are the zeros that are in between two numbers. For example, 7.003, there are 2 zeros trapped between 7 and 3. All of them will count, so there are 4 sig figs in this number. Trailing zeros are significant only if the number has a decimal. So, for example, 5,300 has 2 sig figs because the last 2 zeros are trailing zeros and there are no decimal points. But 530.0 has 4 sig figs because these last 2 zeros happen to be in a number that has a decimal. Leading zeros are never significant. Leading zeros are the zeros that are at the front of the number. It doesn't matter if they are in the front of the decimal or after the decimal. As long as they are in the front, they are not significant. So 0.00038 has 2 sig figs because none of these zeros count. And finally, all digits in the mantissa of a scientific notation are significant. Right? And the mantissa is this first part of the scientific notation. All the digits will count. So there are 3 digits in here. There are 3 sig figs. Let's look at examples. Number 1. 2.518 has how many sig figs? Well, there are no zeros here, so this is a pretty easy one. There are 4 sig figs, 4 digits. Okay? Look at number 2, 3007. There are 2 zeros right here, and they are trapped. Trapped zeros are significant, so we're going to count them. There are 4 sig figs. Number 3, we have several leading zeros. Leading zeros are never significant, so we are not going to count them. There are 5 sig figs. And number 4, 0.004003. These zeros in the front are leading, so they are never significant. These zeros are in between a 4 and a 3, which means they are trapped, so they count. So there are 4 sig figs. Look at number 8. Number 8 is 1.20 times 10 to the 3rd power. This is a scientific notation. We are only going to look at the mantissa, and all of the digits will count. So there are 3 sig figs. Looking at the next set of examples, round to 3 sig figs. Number 11, 12.860. We are going to round to 3 sig figs. 1, 2, 3. 8 is the last digit you want to keep. 6 tells me to round up. So this is going to round to 12.9. Number 12, 3.14159. 1, 2, 3. 4 is my 3rd sig fig. The 1 tells me to round down, which means all of the numbers after that 4 are gone. And in number 13, 1.2635 times 10 to the negative 2. There are 3 sig figs that we want, so 1, 2, 3. 6 is the digit we want to keep. 3 tells me to round down, so this is going to round to 1.26 times 10 to the negative 2 power. Number 17 to 22 asks you to round to 2 sig figs. Look at number 17. 2.517 times 10 to the 1 power. 1, 2. 5 is the last digit I want to keep. 1 tells me to round down, so I am going to round to 2.5 times 10 to the 1 power. Number 18, 1.113, 1, 2. This 1 is my last digit to keep, and the next number is a 1, so it tells me to round down. This will be 1.1. Number 19, 0.0016413. Remember, leading zeros are not significant, so they don't count into our rounding. Okay? So we are going to count the sig figs starting from the 1. 1, 2. 6 is the last digit I want to keep. 4 tells me to round down. So the answer is 0.0016.